Okay, now we are going to start with the assignment chapter. We also refer to this as the Hungarian rule. The assignment chapter, just like transportation, only knows how to do minimization. Many of its features match with transportation, which we will also learn as we discuss further. So the first illustration is about formulation. If we arrange this as a linear programming problem, how will it be set up? Here, it is given that there are 3 programmers and 3 programs. Each person has to be assigned 1 program. Now tell me, how will the formulation be done? What is the rule for formulation? First, do the tabulation. The tabulation is done. Then you have to think. What do you have to think after tabulation? What is our objective? Normally, the objective here is minimization, whether it is mentioned or not. If you see that time or cost is given, like in this question time in minutes is given, then if time or cost is given, it will always be minimization. And how many values are given for that? So many values are given. So for as many values as are given, there will be that many variables. So if we create variables, they will be x1, x2, x3, x4, x5, x6, x7, x8, x9. Alright, so the variables are set. Now, without constraints, we cannot formulate it. We can't see the constraints here, so the default constraint is that each row should be assigned to 1 column. So, each programmer will get only 1 program, the second programmer will also get only 1, the third programmer will also get only 1, and similarly, from this side as well, each program will be assigned to 1 programmer, each program will be assigned to 1 programmer, each program will be assigned to 1 programmer. So what does this mean? In every way, here there will be a 1 default constraint in place. If you just know this, then your sum will be done. So what will we say first of all? Minimize z equals 120 times 1 plus 100 times 2 plus 80 times 3 plus 80 times 4 plus 90 times 5 plus 110 times 6 plus 110 times 7 plus 140 times 8 plus 120 times 9. Subject to number 1. x1 plus x2 plus x3 that is equal to 1. Number 2, x4 plus x5 plus x6 is equal to 1. x7 plus x8 plus x9 is equal to 1. You have to make it 1 on all sides, okay. Fourth, 1 plus 4 plus 7 is equal to 1. Fifth, 2 plus 5 plus 8 is equal to 1. The sixth number 3 plus 6 plus 9 equals 1, and finally there will be a non-negative assumption which is equal to xi greater than equal to 0. The value of I is 1 to 9. The value of I is from 1 to 9. So the main thing here is to put equal to 1 in all of them. That's it. Okay. Many times, you will get this problem in the exam where it is unbalanced. There are 4 rows and 3 columns, so first you will balance it by adding 0, 0, 0 values. There also, you will put 1 if it is a dummy, and then you will formulate it, right? So, its solution is done using the Hungarian rule. The steps of the Hungarian rule are very easy. You learned them in your intermediate classes. You must already know them. That's what I assume. Still, I will give you 2 questions which I feel you should practice. Apart from that, I am telling you what tricks are in which part. So, for example, this question is a simple minimization question. Here, there are 5 mechanics and 5 jobs, so each one will be assigned to 1. If you want to optimize using the Hungarian rules, and if you remember the process to solve it, let me tell you what the flow chart for solving it looks like. The flow chart for assignment, let's say we start with that. We first check whether the problem is balanced or not. Balanced means how many rows and how many columns are there. If the number of rows and columns do not match, then we add dummy rows or dummy columns, assign them a value of 0 and balance it. What will we do after that? After balancing, we will find the initial solution. Basically, what is the method for the initial solution here? Row maximization, row minimization. Row minimization, how is row minimization done? Row minimization means that you go to each row and subtract the minimum value in that row from all the elements of that row. Then you do column minimization. What do you do after that? Column minimization. Then, with the result you got from row minimization, you go to each column and subtract the minimum value in that column from all the elements of that column. What comes next after column minimization? What comes next after column minimization? What will be the next step after column minimization? After this, we draw the lines. This is the step of drawing lines. The step of drawing lines means drawing the number of lines. What does drawing lines say? Draw as few lines as possible to cover the most zeros. What is the rule? Draw as few lines as possible to cover the most zeros. Then we count. Count the number of lines, which we call the optimality test. What is the optimality test? The number of lines should be equal to the order of the matrix. If that matches, then the work is done, so move to the next step. If it matches, then in the next step you move on to boxing. What do you do next? You box the zeros, and after boxing, you conclude the optimum assignment. Then what do you do? You conclude the optimum assignment, and if it doesn't match, then what do you do? If today the answer comes out to be 9, then what do you do? If the answer is 9, then we say that you will have to make an adjustment. If the answer is 9, then adjustment will have to be done. What does adjustment mean? Adjustment means from the uncovered elements in the matrix where you draw the lines, you have to take the smallest value among the uncovered ones and subtract it from all those numbers. You don't have to do anything with the covered ones. At the junctions, you have to add it, so a new adjustment matrix will be formed. Then you will draw lines again on the adjustment matrix, and this process keeps running in a loop here. Then again, the task of drawing lines. Then the optimality test. Alright. If it passes, then it's fine. If the boxing doesn't pass, then adjustment is done again and a loop is formed. Any solution that involves such a loop, where steps are repeated, is what we call an algorithm. So now, of course, I was just revising. I am not solving this sum for you right now. All this should already be solved by you. Before going to the exam hall, let's look at the next question. What's special about it? Maximization problem. If it's a maximization problem, how will we approach it? In a maximization problem, first of all, we will balance it. Yes, that's right. First do the balancing. What will you need while balancing? Dummy is fine, but balancing has to be done first. To balance it, you'll need a dummy, and if the question asks you to maximize either profit or sales, then take the value of profit or sales as 0 for the dummy and introduce it. After that, you will convert it into the opportunity loss matrix. How do you get the opportunity loss matrix? You subtract the given profit from the highest profit. That is, from the highest profit, subtract the given profit. If you subtract it, you will get your answer. If you subtract the given profit from the highest profit, you will get the opportunity loss matrix. Opportunity loss matrix. Did you understand what needs to be done with the highest profit? You have to subtract the given profit. You have to subtract the given profit from the highest profit. Okay, so the opportunity loss matrix will come, and then the steps of the Hungarian rule will be applied to it. The steps of the Hungarian rule will be applied to the opportunity loss matrix. What do you need to keep in mind? You need to keep in mind that balancing has to be done first. Balancing should not be done later. First, do the balancing and then proceed further. Like here, see, there are 5 districts and 5 salesmen, so the problem is balanced, so you can directly make the opportunity loss matrix. For that, highest profit, highest profit. What do you see here? If you look, 41 is visible, so subtract everything from 41, the percent loss matrix will be formed, then apply the Hungarian rule. Okay. Next is the unbalanced assignment problem. What is it? I am already explaining as we go. If the number of rows and the number of columns do not match, then you will say that we will balance it by adding a dummy. In this scenario, you can also have multiple dummies, meaning you can add multiple dummies. For example, if there are 4 columns and 2 rows, then you will have to add 2 dummy rows. If there are 4 rows and 2 columns, then you will have to add 2 dummy columns. So, there can be multiple dummies, but they will be either multiple dummy columns or multiple dummy rows. It cannot happen that in multiples, only one dummy row is added. It also cannot happen that a dummy column is added this way. So the row and column got cut again. If the numbers are not equal, either the rows or the columns will be more. So, sir, will the dummy come in the rows or columns? Alright, if you look at the question here, what is in it? This is a maths question. Alright, so you all know that they love such things. So here it says that a company has received a grant of 50 lakhs, and after that, it says here,
if needed, a supplementary grant will also be given.
Here, we are talking about the company, basically the city corporation. The corporation has received the grant. Suppose the grant has come from the central government saying you should build the road, and if needed, then you can take a supplementary grant, and the cost of repairs and road bidding has come up. There are 5 contractors for 4 types of roads, so this is a balance problem, and to balance it, we will have to add a dummy road. This means that some contractor will get the dummy road. This means that contractor will not get any work, and since this is all about cost, to balance the cost, we add a dummy with 0 cost and balance it out. Now you can solve this and assign it accordingly. Find the best way for assigning the repair work to the contractors and the total cost. You will calculate the total cost by solving to find out the minimum total cost. Alright, when it comes to the dummy. When the column comes, there is already 0 in every row. Okay, there is already 0 in every row, so you can skip the row minimization step. If you want, you can skip it. Even if you don't, it's fine. It can save you time. Similarly, if it comes in the dummy column, suppose now in the dummy column, or if the dummy comes in the row, if it happens by chance, then because there is a 0 in every column, due to the dummy column or dummy row, what can you do? Since there is 1 0 in every column, you can skip the column minimization step. One outcome of the row minimization step is that there should be a 0 in every row. If there is already a 0 in every row, you can skip this step. The result of the column minimization is that there should be a 0 in every column. If a column already has a 0 from a dummy, you can skip the column minimization step. So this is a tip for you on how you can speed up the process in this way. Then, if you solve this, the total cost comes out to be 54. So it was said in the question that we have received a grant of 50 rupees, so should we take some extra supplementary grant or it will cost 4 lakhs. A supplementary grant of 4 lakhs will be required as mentioned here. Alright, and which contractor will not get any work? The one who got the dummy. The contractor who has been assigned the dummy will not get any work. What am I not doing with you right now? I am not solving the entire sum, I am giving you the idea. I will solve the sum I need to do. I will not solve all these simple questions. Alright, so the one who got the dummy will not get any work. Now see, in the assignment problem, if you have to find multiple solutions or alternative solutions, then how did we identify it in transportation problems? In transportation problems, we used to know that when the delta matrix shows 0, 0, it means there is an alternative solution. And how will we know in our assignment problem? When we go to the boxing step, at that time we are not getting a single 0. We are not getting any single 0 and we have to do arbitrary boxing. That's when we understand that an alternative solution exists. So for that, let's think about this particular assignment. Alright, so for example, if you take this matrix, suppose 12 0, 1 8 0, 1 8 0, then what is it? 0, 10, 9, 11 0, then what is it? 0, 8, 5, 3 0, then what is it? 22 0, 0, 0, 4. Then what is it? 14, 4, 0, 0, 0. Alright, so according to this, wherever you see a single 0, box it. I can see 2 zeros here, to here as well, to here as well, and 3 here. Here also I can see 3, so revise, there is no box from here. If we go from here, it's 2, 2, 2 to everywhere. Oh my god! There isn't a single 0 alone from any side, so we'll have to box at least one. Let's say we pick this one and box it. If this is boxed, this will get cancelled. The one below will get cancelled. Now look for a single 0. Here it's 2, here it's 2, here it's 2, here it's 2. From this side also it's 2, again 2, again 2, still nothing. So let's pick a 0 and box it. Suppose we pick this one and box it, then this gets cancelled and this one also gets cancelled. Alright, wherever arbitrary boxing happens, there you will have to cancel the extra 0 in both the row and the column. Then when you come to the third one, if you box here, this one gets cancelled. Then see, you get stuck here again, so you'll have to pick one. If you box here, then this and this get cancelled, so this will be boxed. Now, when you solve it, it might happen that your boxes get shifted here and there. But your answer will still match in total alternatively. So whenever such a case comes in the exam, just try to hint that multiple solutions exist and here we have taken only one of such solutions. If the question never mentions that you have to show multiple solutions, then what should you do? While solving a normal sum, just write a safety note in brackets. Alright, a note for precaution. So here, we are showing many alternative solutions. But you don't have to find and show all of them. You just need to understand it for an idea. In the exam, you don't have to show 4 solutions, just show one and write in brackets that multiple solutions exist and one of the solutions has been taken here. In each case, the total answer will be 191. What comes, comes. Now, prohibited assignment and restrictive assignment. So, how did we handle prohibited assignments in transportation? I had called my mother. Ma, M for ma tends to infinity. Call ma in the prohibited cell and the same approach is used in assignment as well. Wherever you don't want to make an assignment, put m there and the value of m will tend to infinity. Alright, so in this question, prohibited assignment is happening. How is prohibited assignment happening in this? They're saying how many managers there are: marketing, purchasing, HR, finance, corporate law. So, how many managers are there? 5. And they have to be allocated rooms. Room numbers are given 103, 201, 205, 302 and 304. So, there are 1, 2, 3, 4, 5 people and 5 rooms, so the problem is balanced. But some managers do not want to go to certain rooms at all. They have given their preferences like, I want to go to this one, I want to go to that one. So, everyone has given their own ranking order. So now, we have to do such an assignment so that everyone gets their best rooms. For that, in such sums, the first thing we always do is the same. How many rows, how many columns, that is, how many managers, how many rooms, that is balanced. The problem is balanced. You have understood the balance problem. This is the very first step. After that, the second step will be to create a rank matrix here. What will happen? A rank matrix will be created. And what will be the rank matrix? Here, you can write the managers. For example, the manager's name could be marketing, purchase manager. You can put them in any order. You can also put the managers on the opposite side. HR manager, finance manager, company secretary. After this, there will be ranks. The ranks will be written on top, but the room numbers will be here. What are the room numbers? Write them in order: 101, 103, 201, 205, 302, 304. If we go according to marketing, then these three are there: 302, 103 and 304. So, in 302, rank 1 is given, in 103, rank 2, and in 304, rank 3. Then, in 302, rank 1, in 304, rank 2, in 205, rank 3, and in 201, rank 4. For the HR manager, 103 has rank 1, 201 has rank 2, 304 has rank 3, 205 has rank 4, and 302 has rank 5. For the finance manager, 302 has rank 1, 205 has rank 2, 304 has rank 3, and 103 has rank 4. For the company secretary, 201 has rank 1, 302 has rank 2, and 304 has rank 3. Now see, not everyone has been shown the allocation for every room, so wherever there is no allocation on the chart, M will be placed there. Alright. So wherever there is no allocation, no rank, M will be placed there. And now, to minimize this, all the steps will be applied on this, and wherever M has already been placed, once M, always M. What will we say? Once M has come, it will always remain M. Here, M will not change under any circumstances. Whatever the step, he will sit MMM ahead. Don't make M 0, don't make M plus 1, don't make it M minus 2, don't do anything. M will remain M only. It means once mummy has come and sat down, she will sit, she won't move. It's like, here, no one should hit my child. That's it, I'm sitting here. So, no matter what anyone says, we won't move. That's the theory. So you can optimize this. You should try to solve it on your own. If you haven't done it yet, you should do it now. Yes, here comes a great question. Okay, there's one more case which is not given here. But still, I'll discuss it. That is, conditional assignment, which can come in the exam. Alright, so how does conditional assignment work? For example, sometimes it is said that a particular manager should be given only that specific room. So, the HR manager must take room number 103. Otherwise, he says he won't go. He says he won't do any such work. He insists on going with you only to room number 103. What will happen if such a case arises? In this question, from the matrix you have made, now assume that room number 103 is not available and HR is not included, and we will solve the rest on the reduced matrix. Understood? So what will we say in this case? Remove the HR manager and room 103 completely. Remove the HR manager and room 103 entirely and completely from the problem. Then solve on the basis of the reduced matrix. Solve on the basis of the reduced matrix, alright? Solve on reduced matrix basis and in the final answer you put HR and room 103. Include HR and room 103 in the final answer. Alright. So, this is the system. So, whenever conditional assignment is mentioned, meaning it has to be given, then as the saying goes, when both husband and wife agree, what can the priest do? So, the husband and wife elope together. Exactly, HR room absconded with 103. So, whatever is left, that's what we can play with. What else can we do? Now, let's move on to the traveling salesman question. This is an amazing question. This is one of those real questions that I will make you do. Now, in the traveling salesman question, you have to fulfill two objectives. Objective number 1, The very first objective is that the cycle should be complete, and the second objective, objective number 2, is that your cost should be minimized. But the first objective is cycle completion itself. What is the first objective? Cycle completion itself. Then we will look at cost minimization. What is the first objective? It is cycle completion. What is the first objective? It is cycle completion. Okay, well, all right, let's see next. So now, what needs to be done to solve this sum? First, there should be a matrix. Here, some places were blank, which M has already filled in the question. Otherwise, even if blank, it would be written as M. Check if the problem is balanced. Here, there are 5 rows and 5 columns, so it is a balanced problem. So, what will we say first? Balanced problem. Alright, balanced problem or not. So, what do we check for that? How many rows are there? How many columns are there? So, the number of rows is 5. How many columns are there? 5. Both tally. So, what will we say? Balanced problem. Alright, now if it is a balanced problem, then we have to apply the Hungarian rule. What are the steps of the Hungarian rule? Row minimization. What are the steps of the Hungarian rule? Row minimization. The first step is row minimization. So, what does row minimization say? The least value given here is 4, so you have to subtract 4 from everything and write it. But M will remain as M. So what will it become? See, do it yourself. 5 minus 4 is 1. 1, 4, 0, 1. M 1, 4, 0, 1. Then what about the second row? What is the smallest value? In the second row also, the smallest is 4. So 1M301. 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 Then in the third one, what is the smallest value? 6. So to 1M20. To 1M20. Okay, then what is the smallest? 4. So, what will happen in 4? 0, 0, 4, M, 4. 0, 0, 4, M, 4. Then what is the smallest? 5. So, 0, 0, 1, 3, M. 0, 0, 1, 3, M. 0, 0, 1, 3 and M. Is everything clear up to this point? So, this row minimization is clear. Now what will happen? Column minimization. Column minimization is done on this same matrix. From here itself further. So, column-wise, if it's already 0, you can just copy it. If it's already 0, you can copy it. Here, since it's 1, then 3, 2, M, 3, 0. Then 0, 0, 2, M, 3, 1, 1, 0, 4, M. Now, after this, what happens in column minimization? Here, we will apply the steps for drawing lines. So, the line where there are the most zeros, that one first. Most zeros here, so start here. Second most zeros here. Third most zeros here. Fourth line can go anywhere. Suppose I draw it like this. So, n equals 4. But the order of our matrix is 5, right? What is the order of the matrix? 5. 5. Order of the matrix means how many by how many, so it's a 5 by 5 matrix. So, the order of the matrix is 5. Therefore, it's not optimum. If this matched, it would be optimum. Matching is optimum, but not required. We shouldn't draw the lines to make it match. Draw the minimum number of lines. Minimum lines to cover maximum zeros. Now, what do we have to do after this? After this, the next step is adjustment. I don't know how much adjustment will be needed. What is the rule for that? Take the smallest number among the uncovered ones, like 1, and subtract it from all the uncovered elements. M, 0, 2, 0, 1. Subtract from all the uncovered elements. But don't do anything on the covered. These are the covered elements, don't do anything to them. But at the junctions, junction means these 4 points where the lines intersect, added there. So, M, 0, 2, 0, 1 remains the same. Don't do anything to the covered ones. Add at the junctions. Subtract from the uncovered ones, so this is 0, this is M, this is 1, this is 0, this is 1, this is 1, this is 0, this is M, this is 2, this is 0. 0, 0, 3, M plus 1 becomes M, 4 plus 1 becomes 5. Then 0, 0, 0, 3 plus 1 becomes 4, M plus 1 becomes M. Alright, M plus 1 doesn't mean anything, M will remain M. There can't be any changes made to M. Now, again, you have to draw a line over this. The highest 0 visible here is 3. Then 3 zeros are visible here, the highest 0 is 4, so here it's 4. You have to scan every row. Here there are 2 zeros, here also 2, here also 2, here also 2, and here 3. Scan every column. There are 3 and 4. There is 1, there are 2. If there is 1, cover the highest one first. See where the highest 0 is. Scan again, here you see 3 zeros, so this is the highest 2. See where the highest is. You can see to here, then 1 and 1, 1 more and 1. In this way, 5 lines are being drawn. Is there any way to do it in 4 lines? That you will have to find out. For example, suppose you draw 1 line here, then 2 lines here, then 3, then 4, then 5. So even with this, you are getting 5. So you will have to try with a pencil in different ways, like 1 line is coming here, okay, then 3 zeros, 2 lines, then 2 zeros, 3, 4, 5, 6, so it gets stopped. Thinking like this, it can't be more than this. If you are doing more, that means you are making a mistake. That's why, what is the rule? First, the one with 0, then this one, 2, then plain 0 is decreasing, so if it is decreasing, then 5 has come. So therefore, we will say the optimum has come, so the optimum has come. Now what will we do? Now we will do the boxing step. After getting the boxing zeros optimum, we write boxing 0, M0 to 0, 1, write 0, M1, 0, 1, write 1, 0, M2, 0, write 0, 0, 3, M5, write, then 000, 4, M, write, 000, 4, M, right. Alright. So, what do we understand from all this? Wherever we find the single 0, we have to box it. Here, there are 2 zeros, 2 zeros, 2 zeros, 2 zeros, 3 zeros, but there is no single 0 anywhere. If we find it here, then if the column-wise box is done, the row gets eliminated. Then again, if this column-wise box is done, this one gets eliminated. Then again, the same scanning, 2 zeros, 2 zeros, 2 zeros, from here 2 zeros, 2 zeros, 2 zeros, 2 are found. So, if we go to the RB trolley, suppose we pick this one, then this one gets cut, this one gets cut. Alright. Then, where do we find it next? Here we get 2, here we get 2. So from here, this single 0 is found. So by doing this, this one gets boxed. Now, you should know how to do this boxing. Even if you are doing it in some other way, that's also fine. After doing this boxing, Normally we conclude our optimum assignment. But our assignment is only optimum when the cycle is complete or not. So we will check this first. From where to where is it going? How is it going? This is A, B, C, D, E. And here also A, B, C, D, E. So, from A to B, where is it going? From B, it is going to D. From C, it is going to E. From D, it is coming to A. And from E, it is going to C. A, B, C. So what does cycle complete mean? You will have to draw it like this and see. From A it went to B, from B to D, from A to B, then from B where did it go? To D. From D where did it go? From D to A, from D it came back to A. So this means from A to B or B to D it went, but not to the other two customers. From D it came back again. It went to one. This is called the cycle not being completed. From C it went, and then where did it go? Then it came back to C, so it came back to C again. This indicates the cycle is not complete. If the cycle is not complete, we will say a solution has not been found. So now, to get a solution, what will we have to do? We might have to try at the next higher value. That means, if we box at 0, the cycle is not getting completed. Boxing at 0 means boxing at minimum cost. So if the cycle is not getting completed at minimum cost, then we might have to go to the next higher value. What is the next higher value? Against 0, what will it be? That is 1. So, if you box at any 1, you can see there are 1, 2, 3, 4 ones. You have to try boxing at any one of them and see. Pick any one, the rest will remain 0. For that, my rule says break the loop. There is a loop running in A, B, D, and there is a loop running in C. So, you find such a boxing that the coordination happening in A, B, D gets broken. If any one from C, E comes here, something like that happens and it gets connected to the A, B, D route. For example, if you see, we boxed at B, but if we box at E, what will happen? Pick any one of these ones and try by keeping the rest as 0 and see if boxing happens or not. By doing this, I feel that the loop that has formed in B, D, if we push it into K, it will break. The loop will break, so maybe the problem will be solved. You have to break the loop. This is a mantra from my side which will help you get the work done. Then see what happens here. M02, 0 on 0, M10110, M2, 0, 003, M5, then what is it? 0004M. So, I said earlier to break the loop, let's box here. If this gets boxed, then this row will not go to anyone else, and this one also will not go to anyone else. If a row gets boxed anywhere, then its row and column will not go to anyone else. As you box at 0, do the same here. 2 zeros, 1 0, so box this, cross this out. Then 1 0, box this, cross this out. 1 0, so this will be boxed. Okay, if this is boxed, then the one above will also be crossed out. And if it happens, then this will also be boxed. Let's see if this completes the cycle, whether the one who is going can reach the one who is located. A, B, C, D, E are here, and from the top also it's A, B, C, D, E, so A to C, then B to C, D to C, from C to B, from D to A, and from E to C. So what will happen because of this? From A to E. Where are we going from there? Look at the route. From A to E, then from E where are we going? From E to C, so from E we go to C, then from C where are we going? From C we are going to B, then from B where are we going? From B we are going to D, and from D where are we going? From D we stay. So see, all the customers have been visited. There was no break, meaning there was no interruption in between. So this means the cycle is complete. If the cycle is complete, then the assignment that has come now is perfect. If it still wasn't complete, then we would have to try from some other one. And then, basically, like in the institute solution and all, they haven't given all the mantras. What is the mantra? Break the loop, break this loop. If you break the loop, then your chances of completing the cycle increase. Isn't it right? Keep playing trial and error game. Now where from? What will the assignment be? This assignment is final and its cost, you'll write it after looking at the question. This total cost is the final answer. Alright, this is it. So, you understood the traveling salesman, let's move ahead. If you want to listen again, watch it again and do it. So, rewind the video and watch it again. It'll be fun. Now, this is the question which I am skipping. Yes, I am. The session study question doesn't come anymore. It had started coming in between, came a few times, it was a headache. Alright. So now, there's no point in racking your brains over such a big question. If you want to do it, you can go ahead and try. There's no restriction, I'm just not doing it. Sir, in the exam, so brother, we'll pick another question from the options, right? Alright, you have to do the next MCQ on your own. I don't want any carelessness in this. You have to do it yourself, mark it, and circle the wrong answer. And you'll have to revise the ones you got wrong again. Otherwise, you won't be able to do it in the exam. No MCQ should be taken lightly. There are also some comprehensive problems in it. In that, look here, this is a question where it says, there is a methods engineer who wants to assign 4 new methods to 3 work centers. So, since there are 4 methods and only 3 work centers, it's unbalanced, so we'll have to add a dummy work center. What is given here? Time is given, units are given. This problem is a multiple solution problem, meaning you have to find alternate solutions. What is given is that the assignment of new methods will increase production and they are given in the matrix bill. So, this is given in the context of increasing production. So, what does this mean? This is a question of maximization. We are not going to minimize the units. If production is increasing with the method, then we will go for the highest production. So, this is a maximization problem. So, you will have to convert this into an opportunity loss matrix, which will be done by selecting the highest value, which is 12. 12 minus all the values. Where will you put the dummy? You will put the dummy in the original matrix. First, you will add the dummy to balance it, then go to the loss matrix. And then, how will you know if there are multiple solutions or not? In the end, if boxing or RBT is happening, then multiple solutions exist. You will check that, right? If not, then you have to set and try it out. And the answer hence are given here. You can see whether your answer is matching or not. The highest one is being selected, right? So, this is a maximization problem. This is the final answer, which I have circled 10, 12 and 8. 2 is getting the dummy, so the highest values are being selected. 10 is the highest one. So, in the maximization problem, it is not written anywhere, but it was left for you to understand by the institute. Now look at this one. There are 4 clerks and 4 tasks. A dash is given, which means, for example, assistant 2 cannot be assigned to task A and assistant 3 cannot be assigned to task D. So, because of this, these are prohibited assignments. Where it is prohibited, you will put an M there. And here, the time is given, so it is a minimization problem. So, you can do it easily. Now, if it was written here that assistant 2 has to be sent to task A and assistant 3 has to be sent to task B, then what would happen? Then, we remove assistant 2 and task A and we also remove assistant 3 and task B. Whatever is left, we make a matrix of 1, 4 and C, D. We make a matrix of 1, 4 and C, D, which comes out to be 5, 6 and 4, 2. And based on this, what do we do? Tell me. Based on this, we apply the Hungarian rule. But that is not the case here. Here, it is the case with M. So, I have explained it to you like this. Now look at this question. What is it that we don't know how to make the matrix here? This is a maximization question, but the matrix is very important. The company is saying there are 4 zones open for 4 salesmen available for assignment. So, there are 4 salesmen and 4 zones. Each salesman has to be assigned to one zone. Each zone would bring in this much sales. Zone A will bring in this much, B will bring in this much, C will bring in this much, and D will bring in this much. And all 4 salesmen have different abilities. If they are working under the same conditions means if they go to the same zone, their sales would be as follows. Q will bring in 7, R will bring in 5, S will bring in 5, and T will bring in 4. The criteria is to maximize the expected sales. This is the intuitive answer. So, assign the best salesperson to the richest zone, the next best to the second richest zone, and so on. You can verify this by the method of assignment. It naturally makes sense that, of course, the best zone should be assigned to the person who brings in the highest sales. Here, no matrix has been given, so how will the matrix be formed? You can take the manager, for example. Suppose, let's say, not the manager but the sales manager. No, not the manager. Take the salesman, for example, P, Q, R, S. Then here, take the zone. In the zone there are A, B, C, D. What is A, B, C, D in the zone? Then the total for the zone is 1,26,000, and here the total for the zone is 1,05,000. Then here, the total for the zone is 84, and then the total for the zone is 63. Now, ratio has 7, 5, 5, 4, so split this according to the ratio of 7, 5, 5, 4. 7, 5, 17, 4, 28 happens, so 7 by 20, A. It will go the same way in all. 126 by 28 into 731 500. Then 520 to 500, then 520 to 500, then 418,000. Break down this 1,05,000 similarly. 1,05,000 multiplied by 7, then divided by 28, that gives us 26,250. Next, 1,05,000 divided by 28 results in 18,750. Then, once again, we have 18,750. Moving on, for 4, what will it be? That would be 15,000. Now, considering 84,000, so 84,000 divided by 28 and then multiplied by 7 gives us 21,000. After that, we have 35. Sorry about that. This will come to 5 cool towels, 15. And this will come to 12 in total, which, as expected, means something is going wrong. What? 84 by 28 into 7? How is it 5, 15, 15, 12, 30, 12, 42? Why is the total not matching? Because I have made a mistake from 21, taking 28, we are doing it. What is happening? 7, 5, 5, 4 makes 21, we are doing it from 28. So how will it match? So 7 and 21, 1,26,000. 21 into 7, 42, 5 comes, 30, then 30 and 24, alright. Then 100, 5000 times 21, 5000 into 7, which gives 35, then 25, another 25, then 20. Next, 84,000 divided by 21, 84,000 by 21 into 7, which results in 28, then 520, and finally 320. Now, then for 4, it is coming as 16, then 63 divided by 21 into 7. In 21, 5 it is coming as 15, 15. And with that, the 12th and final step is now complete. We have successfully finished all 12 steps, marking the end of this process. So, the answer has come from the salesman and the zone. The answer has come from the salesman and the zone. This has become the matrix. You can further simplify this. You can make a matrix in rupees in thousands. Alright, if you make a matrix in rupees in thousands, it will become even simpler. Then you can easily solve it. And this is a maximization problem. So first, the opportunity loss matrix will be made. This way, you can simplify the matrix T 25, 20, 15, 30, 20, 5, 20, 15, 20, 4, 20, 16 and 12. To make the opportunity loss matrix, what do we do? The highest value is 42, so 42 minus the given value gives the opportunity loss. Done. Next, in the fourth question, this is the question. I am not solving it, just showing you. It looks big, but it's just that there are a few more numbers. In this, there are 6 operators and 6 machines already. Then, there is talk of bringing in a 7th new machine, so to balance it, a dummy operator will be needed. And here, the time is given, so it's a minimization problem. So, it's unbalanced and a minimization problem. Great. So, the question is asking, tell the allocation of operators to the old machines. To achieve minimum operation time, the first part must be done without the dummy, using only old machines, making it a 6 by 6 problem. In the second part, reset the problem with the new machine, find operator allocation, and comment on whether advantageous. Replace machines to reduce operating time. Only. This is a 7 by 7 problem, as you can see. In question 4, there are 2 parts. A and B part is a balance problem. I will rather write unbalanced minimization here, unbalanced only here, alright? First, you have to solve the minimization problem on a 6 by 6 matrix, meaning 6 operators and these 6 machines. First, you have to solve the sum on this. The assignment problem is balanced because there are 6 operators and 6 machines. Whatever total answer you get from that, just write it down. Then, when the 7th machine comes in and there are only 6 operators, you have to add a dummy operator accordingly, okay? Now, here comes another question which I also need to explain to you and make you solve. This question is about airline idle time. Like in airlines, what happens is that they go to and fro from one city to another, so the crew members board from here. Suppose they are going from Delhi to Jaipur, so they will board from Delhi, and then we have to bring them back to Delhi to release them. We can't just leave them in Jaipur, right? So if they boarded from Delhi, they will return to Delhi. Now, the thing is, the time from Jaipur to Delhi can't be such that the flight goes and immediately comes back. That's not possible. The time is allotted by air traffic and you can only fly at the scheduled time. So, if a crew member joined duty at 7 o'clock, then they worked for 1 hour. By 8 o'clock, the first flight from Delhi reaches Jaipur, But does the crew have 4 options to return? So, if they come back by this, or by that, or by another one, or yet another one, then in between these options, there is some idle time in between, so that idle time. We have to minimize that idle time, so who is responsible for that? Many times, there is a requirement in flights that a flight cannot take off immediately after landing because cleaning has to be done, refueling is needed, or there is some permission or checking to be done, so there is some minimum idle time as well. So, like in this question, it is given that crew members must have a minimum layover of 5 hours. Now, if the pilot flies the plane and is made to fly again immediately, there could be an accident, he must be given rest. Even though the flight is 1 hour, before that the person wakes up early, there are many checks, and handling everything takes time, the person gets tired. So, it is very important to give them rest. That's why there is a minimum layover time, during which the flight is also prepared and the crew gets to rest as well. So, this is the layover. If we give them this, then our own idle time will increase a bit more. Meaning, there will definitely be a minimum of 5, but it could be more than that as well. So, our goal is to minimize this idle time, and for that, we have to follow certain steps. What are these steps? What will be step number 1? Look, I will explain everything to you in detail. First, you learn with me, then you do it yourself. Don't rush right now thinking you have to do step number 1 immediately. Suppose the crew's hometown or home city is Delhi, let's say, so they will board from Delhi and deboard at Delhi. This is step 1, so someone will board from Delhi. If it's flight number 1, pay attention to the flight number, it's for going. So, they reached 7 o'clock, worked an hour, and reached Jaipur 8 o'clock. Now, when coming back from Jaipur, the flight number will be 101. What time is that? It's at 8 o'clock. It will take off from there at 8, but if it arrives at 8, it can't take off at 8. At least 5 hours rest is needed, so when will it take off? Next day at 8 in the morning, so there will be an idle time of 24 hours. We are figuring out the idle time. This is where the real effort is happening. A full 24 hours. After working, again reached at 8 o'clock, when will it take off? At 8:30. If it takes off at 8:30, it will fly as flight number 102. From 8 to 8:30 is half an hour. Half an hour is rest time, otherwise next day it's 8:30, 24 and a half hours. For 103, flight is at 12 o'clock. From 8 to 12 is 4 hours, 4 hours will be counted, otherwise 24 plus 4 is 28 hours. 24 plus 4 will be 28. You'll have to mark it as exceeding by 4 hours. Then let's come to flight number 104. So, for the 8 o'clock one, it will be at 5:30, 5:30. So tell me, from 8 to 4 is done. 12 means 4 hours. And then 5:30, 4 plus 5 and a half. 9 and a half hours, take 9 and a half hours. You'll get overtime if it's over 9 and a half or 5. If under 5, count it next day. Think this way. What will happen in flight 2? How much idle time will there be in flight 2? From 7, the flight took off at 9, reached at 9, and from 9 o'clock they'll return with flight 101. How much rest should they be given? It can't be from 9 to 8, that's not possible. So, 8 the next day means 23 hours. Then 8:30, so 23 and a half hours. From 9 to 12, 3 hours, but that's not possible. So, it will be 27 hours. 24 hours the next day, then from 9 to 5:30. So, because it's 5:30, 3 plus 5 makes 8 and a half hours. 3 and 5 is 8:30. 3 plus 5.5 is 8.5. Flight number 3. What will be? Flight number 3, 2:30. From 2:30 to 8 o'clock, how much time is that? From 2:30 to 8 o'clock the next day, how many hours will that be? 12 hours. It will be 2:30 in the morning. 12, 5, 17, 17 makes 7.5 Virat. So, it is coming to 17.5. Then, since it's 8.5, it becomes 18.
Then, from 2:30 to 12, it will be 24 hours, so it will be 2:30.
Back again. It is 2.5 hours less than that. So, it comes to 21.5, 21.5. How do we work it out? From 2:30 to 2:30, it becomes a full 24 hours. We did a reverse minus. From 2.5 hours. Or count on your fingers from 2:30 to 2:30, 12 hours, 2:30 in the afternoon. Then after 2:30 in the afternoon, at 12 and 8, that's 20 hours. So, it becomes 10:30. Then it's 12 o'clock. It's 21.5. What about 7:30? If it starts from 7:30, then 5:30 would be the same day. But 5:30 is not possible, so it will be the next day. 22 hours is correct. Sorry, I made a mistake. Even the 2.5 one doesn't get completed. 2.5, 7:30 to 5:30. 2:30 to 5:30 is 3 hours, otherwise 25 hours. From 2:30 to 5:30, it will be 3 hours. Otherwise, 24 plus 3, that's 27. Sorry, it will be 27. You can't fly after just 3 hours, the minimum layover is 5 hours. So, like the minimum layover, it's less than that. You'll have to consider the next day. After 24 hours, it will be 2:30 p.m. Then, with 3:27, that's the kind of layover you're getting. Because of the 5-hour condition, now let's look at Flight 4. In Flight 4, from 7:30 in the evening to 8 in the morning, how many hours is that? 12.5, 12, 12.5. Then from 7:30 in the evening to 8:30 in the morning, that's 13 hours. Then from 7:30 in the evening to 12 noon. Next day, 12 noon means 12 hours, it will be 7:30. Then 4:30, 7:30, and again 4:30, 7:30, 8, 4, 12. So 7:30 and 4:30, that is 12 and 4. 16.5 times. Think for yourself, work hard, do the mental calculation from 7:30 to 12. Next day, 12 in the afternoon, so from 7:30 to 7:30, 12. After that, 12, 4.5 hours more. Then from 7:30 to 5:30, from 7:30 to 5:30, meaning next day, 22 hours. This is how step 1 happened. Similarly, step 2 will be created. He is saying, suppose the crew is based and his home city is Jaipur. So if he has idle time in Jaipur, then what will happen? Flight 101, 102, 103, 104, 1, 2, 3, 4. Now think from this side. So he started from 101 like this. The crew member boarded at 8 o'clock. At what time did he board? At 8 o'clock. The crew member boarded at 8 o'clock. From that side, from the right side, you work till 9:15. Now, from 9:15, if he flies at 7 in the morning, then it will be 7 in the morning the next day. It's possible. So how much time will there be till 7 in the morning the next day? If it is 9:15. 9:15, 9:45, you'll need to pay close attention to these timings. If it's from 9:15 to 7 in the morning, if we take 9:15 to 9:15, it's 24 hours. In the end, we will come back from that. Okay, from 9:15 to 9:15, it becomes 24 hours. If we subtract 2 hours, it will become 7:15. But our flight is at 7 o'clock, so if we do 24 minus 2, it becomes 22. Now, from 22, we have to subtract another 15 minutes, so what will it be? Think about it. This will be 21 hours and 45 minutes, right? 21 hours 45 minutes. So if we convert 21.45 minutes into hours by doing 45 divided by 60, it will come to 21.75 hours. Alright, it's 21 hours and 45 minutes. We converted 21 hours 45 minutes to 21.75 hours by dividing 45 minutes by 60 and got 21.75 hours. Now you add and cross-check. If I add 21:15, what will happen? If I add 21:45, 45 minutes, it will be 10 o'clock. Add 45 minutes to 9:15. If it becomes 10 o'clock from 10 o'clock to 7 o'clock the next day, is it 21 hours? Tell me. At 24 hours, it will be 10 o'clock. Subtract 3, so it becomes 21. From 9:15 to 8 in the morning, from 7 to 8, add 1 hour. 22.75 comes from here, 22.75 on this side. Then from 9:15, then 1.5. What will be 1.5? Tell me. From 9:15, 1.5, what will it be? From 9:15 in the morning, how long is 1.5 from 9:15? See, from 9 to 1.5, first see 10, 11, 12, 1. If we are counting 10, 11, 12, 1, then it becomes 4 hours. How many hours is it from 9 to 1? 10, 11, 12, 1, that's 4 hours. From 9:15, it's 1.5 hours, so 4 hours 15 minutes. If it's not in 4 hours 15 minutes, then add 24, so it's 28 hours 15 minutes. 28 hours 15 minutes means 15 minutes means 28 hours 15 minutes. If you take 15 minutes in hours, then it's 28.25 hours. Can you understand how much maths is in this? By adding these 15 minutes, they've made a mess. From 9:15 to 6:30, from 9:15 to 6:30, it's the same day. No, it's the next day, it's 6:30 a.m. It can't be a.m., this will be p.m. How can it be 6:30 a.m.? The flight will not take that long from 6:30 a.m. to 7:30 p.m. This should be p.m., right? The route looks completely messed up. There's a winding error here. If it's from 9:15 to 6:30 in the evening on the same day, then from 9:15 to 6 hours is 3:15, then 3 more hours is 6:15, so 6 plus 3 is 9 over 15 minutes. 9 over 15 minutes means 9.25 over. 15 minutes means 0.25. Now let's take 102. Let's take 102 from 9:45 to 7 o'clock. From 9:45 to 7 o'clock. From 9:45 to 7 in the morning. From 9:45 to 7 in the morning, if we add 24 hours to 9:45, what will it be? By adding 24 hours, it will become 9:45. Then if we go back by 2 hours, that is 22 hours, it becomes 7:45. Now, from 7:45, we have to subtract 45, that is, from 22, we have to subtract 45. So this will be 21 hours and 15 minutes. 21:15 means 15 minutes, that is, 28.25 overs, 15 minutes means 0.25 overs. Now you can check by adding. If we add 15 minutes to 21 hours 15 minutes, it will become 10 o'clock. And if we add 21 hours, it will become 7 o'clock. Then from 9:45 to 8, after 21 hours 15 minutes, 1 more hour, and 20 to 15, 20 to 25, from 21:25 to 22:25. Then from 9:45 to 1.5, 1.5 of the same day, so 10, 11, 12, 1. If it becomes 4 hours, what will happen? It's 1:45. It hasn't been 4 hours yet. Subtract 15 minutes, it's 3 hours 45 minutes, so 3 hours 45 minutes. Now, 3 hours 45 minutes means 3.75 hours. Now, we can't take 3.75 overs because our minimum level is 5, so it will come to 27.75, 27.75. Are you able to understand this much maths? Only then will my effort be worthwhile. No one could have done this on their own, that's why I'm making you do it. Then, see how much it will be from 9:45 till 6:30 in the evening. From 9:45 to 6:30 in the evening, if we add 6 hours, it becomes 3:45, add 3 more hours, it becomes 9 hours, so it will be 6:45. Subtract 15 minutes from 9 hours, that is 8 hours 45 minutes, which means 8.75. Alright, 8.75. There's half an hour extra here, so there's half an hour less in all. You can look at it however you want. Is this correct or not? Now let's do the one with 103. What is that? From 1:15 to 7 o'clock, from 1:15 to 7 the next morning, 12 hours from 1:15. If you count 12 hours from 1:15, it becomes 1:15 in the morning. Then if you add 6 hours, it becomes 18 hours. If you add 6 to 12, it becomes 18 hours, so adding 6 to 1 makes it 7:15. First, just think from 1 to 7. In that way, it comes to 18 hours, it is coming to 18 hours only, right? From 1 to 6, if you add 6 to 1, it becomes 7 o'clock in the evening. For 6 in the morning the next day, 12 plus 6 is 18. From 1:15, that means you have to subtract 15 minutes. So if you subtract 15 minutes from 18, how much will it be? If you subtract 15 minutes from 18, it will be 17:45. 17.75. 17.75. Then here it comes to 8 o'clock. So at 8 o'clock, 1 hour will be added. 18.75. Then at 1:30. What about 1:30? Can it be the same day? From 9:45 to 1:30, 10, 11, 12, 1. If you add 4 hours, it becomes 1:45. But if you subtract 15 minutes from that, it's 3 hours 45 minutes, that is 3.75 is coming up. But since the minimum is 5 overs, if we add 24 to that, it comes to 27.75. 27.75. Check again, what time is it from 1:15 we guys 1:15 to 1:30. Sorry, I made a mistake. Let me check 103 once again. For number 103, from 1:15, I had already checked from 9:45. That's why I felt I was making some mistake. Let's do it again. What will it be from 1:15 to 7 in the morning? What was it for 18 hours from 1:15 to 7 in the morning? It was 18 hours. If you add 18 hours, it will become 7:15. So if you subtract 15 minutes from that, that means if you subtract 0.25, then subtracting 0.25 from 18 gives 17.75. Then 1 hour got added, so I made it 18.75. Then from 1:15 to 1:30. That means it happened just 15 minutes later. A flight can't take off just 15 minutes later. So 24 hours 15 minutes. 24 hours 15 minutes means 24.25. Then after 1:15, it's 6:30. So how much will that be? It's 5 hours 15 minutes. It's coming to 5 hours 15 minutes. 5 hours 15 minutes means it will remain 5 hours 15 minutes only. 5.25. What will happen in 104? This is taking a lot of time. Yes, good question. It's taking a lot of time. You are absolutely right. If this question comes in the exam, you should skip it. It's taking too much time. What to do? And if you have a lot of time and nothing else is coming to mind, then you have to do it. From 6:45 to 7 o'clock in the morning, how many hours will that be, sir? If you are saying to skip it, then why are you making us do it? I'm just showing my power. You can see what all sir knows. That's why I'm making you do it. Do it calmly. Enjoy from 6:45 to 7. If you can't do it, then stop, enjoy, just keep watching. Sir, what are you doing? Sir is playing from 6:45 to 7 in the morning, so 12 hours after 6:45 will be 6:45 in the morning again, plus 15 minutes, so 12 hours 15 minutes, meaning 12.25. Then, 1 hour after 6:45 in the morning will be 13.25. Then, from 6:45, if it's 1.5 hours, what will that be? It will be the same day. No, it's not 1.5 in the morning, brother. If it's 1.5 in the afternoon, then how can it be the same day? So, we'll add 12 hours to 6:45. So, from 6:45 in the morning, if we add another 6 hours, then 18, so we've reached 12:45. After 12:45, if you add another 45 minutes, it will become 1:30. So from 6:45 till here, it's coming to 18 hours and 45 minutes. Look, if you add 45 minutes, now it will become 7:30. 7:30 plus 1.5 will make 18 hours, so 18 hours and 45 minutes, that is 18.75. Then 6:45 becomes 6:30. 6.5 of 6:45. That is showing on the same day. But if it completes a full round, then after 24 hours, subtract 15 minutes from 6:45, so it becomes 23.75. 15 minutes less means 0.25 over is 15 minutes. That's why you are seeing this effect. Anyway, now this step 2 is finished. This has become very calculative. Normally, there shouldn't have been 15 minutes in the sum. If it was 8 to 9 here as well, it would have been done quickly, right? But this one took a bit more time. Anyway, now after this, we have to do step 3. What we have to do in step 3 is, by comparing these two, we have to make a minimum idle time matrix. How will that be made? It will be made by comparing 1 and 2. And what do we have to do in that? For flights 1, 2, 3, 4, here also we have 101, 102, 103 and 104. So according to this, between 24 and 21.75, take whichever is lower. 21.75. And where is that from? From Jaipur to hometown. Jaipur. 23 to 22.75, lower is 22.75. Jaipur between 17.5 and 28.25, 17.5 for Delhi. Between 12.5 and 9.25, 9.25. Jaipur. Then for 102, it's 24.5 and 21.25, so 21.25. Jaipur. 23.5 and 22.25, so 22.25. Jaipur. 18 and 27.75, so 18 for Delhi. Then 13 and 8.75, 875. Jaipur. Then 28 and 17.75, so 17.75. Jaipur. Then 27 and 18.75, 18.75. Jaipur. 21.5 and 24.25, so 21.5 for Delhi. Then 16.5 and 5.25, so 5.25. Jaipur. Then 9.5 and 12.25, so 9.5 for Delhi. Then between 8.5 and 13.25, whichever is lower, 8.5 for Delhi. Then 27 and 18.75, so 18.75. Jaipur. Then what is it? 22 and 23.75, so 22 for Delhi. Okay. Now what will we do in this? We will apply the Hungarian rule. For the Hungarian rule, it is a balanced problem. Alright, step 1. Then what needs to be done? On this, apply the Hungarian rule and find out the optimum assignment. Apply the Hungarian rule here. Then what needs to be done? I am solving the entire row minimization for you. You just keep watching and enjoy. Don't skip. If you skip, Kali Mai will come and take you away. So, from the lowest value, 9.5, you have to subtract it from everything. 21.75 minus 9.5 is 12.25. Then 21.25 minus 9.5 is 11.75. 17.75 minus 9.5 is 8.25. And this is 0. Next lower is 8.5. So 22.75 minus 8.5 is 14.25. 22.25 minus 8.5 is 13.75. 18.75 minus 8.5 is 10.25, then 0. Then in 17.5, which is the smallest here? 17.5 is showing here, so this is 0. This is 0.5, this is 4 hours, and 18.75 minus 17.5 is 1.25. Then, since it's 5 and a quarter, from 5 and a quarter to 4, then 8.75 minus 5 and a quarter gives 3.5. This is 0, and this is 22 minus 5.25, which is 16.75. Now, column minimization. So here, column-wise, it's 12.25, 14.25, 0 and 4. Here, the minimum value is 0.5, so 11.25, 13.25, 0 and 3. Then 8.25, 10.25, 4 and 0. Then 0, 0, 1.25, 16.75. Now, we have to draw the lines. 1 line, 2 lines. It finishes in 3 lines. Since it's not optimum, we need to make adjustments. Adjustment number 1, what is the minimum value? It is 8.25, so if you subtract 8.25 from 12.25, what do you get? 4. Then, if you subtract 8.25 from 11.25, you get 3. Then comes 0. Then, on the cover, the same 14.25 and 8.25, so it comes to 6. Here it comes to 5, here it comes to 2, then 0. Then 0, 0, 4, and if you add 8.25 here, it becomes 9.5. Then 4, 3, 0, in 16.75 and 8.25, it will come to 25. Now draw a line where you see the most zeros to zeros to zeros to zeros. Then it finished in 3 lines, so it is not optimum. There will be adjustment 2. So, in adjustment 2, which one is the smallest? 3. You have to subtract that from everything, so 3 0, 4 minus 1 0. Copy it again, then 3, 2, 2, 0, 0, 0, 7, 9.5. If you add 3 to 9.5, it becomes 12.5. Then by doing 4 minus 3, you get 1. By doing 3 minus 3, you get 0. 0, 25. So, what is there in this? Now see. The one with 3, 0, then 2, 2 and 1, it matches. These 4 lines have come. So therefore, the optimum has come. So now what we have to do is boxing. After this, what do we have to do now? Boxing. The next step is boxing the zeros. So 1 0 0 0 3 2 2 0 0 0 7 12.5 1 0 0 25. So wherever you see a single zero, box it. Here you saw it, this one is cut. 2 zeros, 2 zeros. From here, this single one is seen, so this one is cut. Then 2 zeros, 2 zeros. From here also 2 zeros. Now here it's a tie. If it's a tie, then box any one of them. So this is your optimum assignment. So what will be the conclusion? There are flight numbers 1, 2, 3, 4 and their pairs are formed accordingly. From there, this is Delhi to Jaipur and the Jaipur to Delhi one is 101. It was here, right? 101, 102, 103, 104. So connect this to 102, connect this to 104, connect this to 101 and connect this to 103. And what will be the idle time? The idle time will be as given in your matrix. For 102, it is 21.25. For 104, it is 8.5. For 101, the third one, for 101, it is 17.5. And for the fourth one, for 103, for the fourth one and 103, it is 5.25 and also write its base city. What is the hometown? Base in 21.25, what was written? Jaipur. So in 21.25, it's 102, right? So Jaipur, here it is, this J written here is Jaipur. For the 831, it's Delhi. Then for 1730, it's Delhi and Jaipur, Delhi Jaipur. So what does this mean? This flight that will go from Delhi to Jaipur, it will return from Jaipur to Delhi with number 102 and during this time, this will be the idle time and the crew members should then board from Jaipur. It should be someone based in Jaipur. So he will come from Jaipur to Delhi and then go back from Delhi to Jaipur. This will have the least idle time. Alright, so this is how pairing is done. All this is a very useful solution in the real world. In the real world, software is made for everyone. The total is coming to 52.5. If you look at the answer here, the answer is given here and this is the alternate answer. Alright. We are getting a different answer. But an alternate solution can also come up, right? Like I had boxed these two here alternatively. If I had boxed the opposite two, this one and this one, then it would have matched the answer given. It was a great sum. It was interesting. This time, revision is done. You have understood the depth of teaching in SDC. Everything is covered. There are some people like that. Some of our students are so talented, just think all these techniques they have learned. In the real world, they will face many such situations. When they went to work, they remembered what they had studied and by using it, by applying the transportation algorithm, they found an optimum solution for that company. And when they did that, they were made the head of that particular department, the logistics department of transportation. Alright, because not everyone has much understanding. Everyone is busy in their own world. No one feels the urge to use what they've studied. What happens is people remember things till the exam. When you people pass and sit in the campus or go for a job interview, you forget everything you have studied. You forget everything. You can't even recall what all you have studied. According to me, for at least 10 years, don't give away or throw any of the books or notes you have studied for 10 years. You never know when something will come in handy in life. Sometimes, even just sitting free and glancing at chapter names, you'll remember there was something like this. So, when you work in the real world, you have to use this knowledge. Right now, it's built into the software, that's fine, but if not, you'll have to learn to use all this in Excel. How all this is done in Excel, I have uploaded everything on YouTube. If you look, you will find it. But anyway, with this, the assignment chapter is over. Now, this is something to celebrate. Alright, great, thank you. Okay guys, how are you all doing? Are you enjoying studying or not? Tell me quickly, and now we will do game theory, yes. Game theory was written in 1944. When was it written? In 1944. What is special about this chapter? That it is very easy, but still there is something to learn in it. Alright, so it was discovered by John von Neumann and his friend Oscar Morgenstern. Alright, when they were studying economics, they felt that economics is nothing but a game between two companies, and two companies are trying to compete with each other, where one should win and the other should lose. Alright, so based on this, two types of games were thought of here. One is a zero-sum game and the other is a non-zero-sum game. What is a zero-sum game? In this, whatever player A wins, that is exactly what player B loses. So, as much as player A wins, by that same amount, player B will lose. This is called a zero-sum game. Alright, the amount won by the winners is equal to the amount lost by the losers. Alright, and then there is the non-zero-sum game where, for example, the winner might win 1,000 rupees, but the loser only loses 200 rupees, something like that. Where the sum of gain and loss is not equal to 0, meaning the winner is winning more, the loss is less, or the win is less and the loss is more, that is called a non-zero-sum game. Then, to play the game, you need some strategies so that you can achieve victory. So, two types of strategies have been mentioned, pure strategy and mixed strategy. What has been mentioned? Two types of strategies have been mentioned, pure strategy and mixed strategy. Pure strategy means that the outcomes in the game are determined. If you do this, then this will happen. In mixed strategy, the outcomes are probabilistic. This one is deterministic, that one is probabilistic. So in mixed strategy, the sum of probabilities is used to solve the sum. Technically, we say that if a saddle point exists in the game, if a saddle point exists, it means in a way that it is a zero-sum game. You can think of it as a zero-sum game. It means that if one player's gain is exactly equal to the other player's loss, then it is a pure strategy, meaning whatever player A wants to do, player B will also want to do the same. If this is the case, then it is a pure strategy. In a mixed strategy, one player tries to guess the other player's strategy, thinking that if I do this, maybe the other person will also do that, but there is no guarantee that they will actually do it. That's why you feel that you will win this much, but the other person might do something else, so your loss could be different as well. That is called a mixed strategy. And technically, we say that there is no saddle point in this. If there is no saddle point, it means it is not a zero-sum game, and then it becomes a mixed strategy. Alright, so now let's move on to the sum, and by looking at the sum, you'll understand what kind of calculations you might be asked. For example, let's take this example. This is a bit of a mixed strategy system, but still, let's try to understand this. This is called payoff matrix. It's called a payoff matrix. In the payoff matrix, there is one player on this side and another player on the other side. This shows that if player A takes action A1, then player B will take action B1. If it takes action A2, then B will take action B2, and we already know these values.
We get to know this from the question itself.
So, we say that these values are inflow from the angle of A1, outflow from the angle of B1, inflow from the angle of A2, and outflow from the angle of B2. So, whatever A1 or A is getting, that is written here. The inflow for A is written and the outflow for B is written. You need to understand this. Right now, the data is arranged like this. You can think of it that way. Alright, so A has A1 and A2B has B1 and B2. If A has out inflows, then B has outflows. So what will A want? A will want its inflow to be maximized. A will want its inflow to be maximized. And what will B want? B will want its outflow to be minimized. So, these people are playing for their own benefit, and accordingly, they will choose their own strategy. Based on this, they will choose their own strategy. Now, what will that strategy be? That we have to find out. The method they use to choose that strategy is called maximin by the player. What is it called? Maximin. Maximin means he is thinking, what is the minimum I will get at the very least? For example, if you look here, what is the minimum you will get? You will get 1. In this, at the very least, you will get 1. If A plays a 1, B will play either B1 or B2. Playing means someone will make a move, some competitor will take an action, or it could even be a customer. The customer will quote some price. If the A1 product is shown, we will quote 1 rupee or 5 rupees. Just think of it like that. Anything can happen. There are two parties. So either he will say this or he will say that. So what can I think? If I go to sell A1, then at the very least, I will get 1 rupee. If I go to sell A2, then at the very least, I will get 2 rupees. So, in the worst case scenario, what will he get? That is the minimum, and out of these minimums, since he wants to maximize his inflow, which one will he choose? For his own benefit, he will choose 2. So, A's strategy is a do right, and that strategy comes from the maximin principle. Always remember, on this side, there is always the maximizing player, and his strategy comes from the maximin principle. And B, who is thinking about the outflow, is called the minimizing player. His strategy comes from the minimax principle. Minimax means, what will he think? Oh man, if things go bad for me, then with B1 I will lose 4 rupees, and if it goes worse, then here I will lose 5 rupees. So first, you have to see what is the highest loss and then try to reduce it. So among these two, you have to take the minimum. This is minimax. Among these two, you have to take the minimum, so the strategy that A is getting is a 2 its value, the benefit he is getting is 2, and the strategy that B is getting is B1 and its value is 4, meaning this is A's gain, so for B, it is a loss. This is implied. It will be a loss for B. On this side, there is a loss, and on that side, a gain. So what we understand from this is that there is a net difference for us. Whatever is A's gain is B's loss. Such a match is not happening, so when this match is not happening, it means there is no saddle point in this, there is no pure strategy. This is not a zero-sum game. The net is not coming out to be 0. So what is coming in the net? -2 is coming, so this isn't a zero-sum or pure strategy. No saddle point, so it's a mixed strategy. Mixed strategy means that whatever benefit A gets, it is not necessary B will have an equal loss. Alright, so by solving this first, we can understand whether it can be solved by pure strategy or not. Let's see that. If it could be solved by pure strategy, assuming it could be solved by pure strategy and we got the answer, we would have left it at that. But since it is not equal to 0, therefore it is a mixed, what do we call it, mixed mystery? Therefore it is a mixed strategy. Therefore a saddle point does not exist. Therefore it is a non-zero sum game. Understood. Now what do we have to do next? After this, since we have to solve using the mixed strategy, for mixed strategy, rule number 1 is that your matrix should be 2 by 2. If the matrix is not 2 by 2, then you will have to reduce it to make it 2 by 2. How to show that, we will see later, and rule number 2 of the mixed strategy says that you have to apply the odds method. In the odds method, you calculate the odds and then find the probability. For example, if you can see this matrix in the question where it is given as 1, 5, 4, 2, then you will have to calculate its odds. How are the odds calculated? Odds will be calculated here as well, both in the row and in the column. So, how are the odds calculated? When you calculate the odds here, you will subtract these two. B1 minus B2, this is B1, this is B2. So by doing B1 minus B2, you will get to here. And on this side, by doing a 1 minus a 2, you will get 4. Now, since this is coming in minus, we don't take it as minus, we always take it as plus. Then, how will the odds come here on this side? Opposite, like suppose from this column to this side, it will be 3, then from this column to that side. That is also coming as 3. Alright, these are the odds, this is the first, this is the odds method. Next is rule number 3, or you can speak within the odds method only. In the odds method, we have found the odds. Now, from this, you have to find the probability. This is a 1, this is a 2. Alright, so now we will find the probability of a 1 and a 2. P of a 1, P of a 2, alright, so what will be P of a 1? Which is to divide it by 6, to by 2 2. 4 by 6, so this is coming to 1/3, this is coming to 2/3, this is coming to 1/3, this is coming to 2/3. In the same way, you can also find P of B1 and B2, or if you find B1 and B2, then how will it come? That is, this by total 3 by 6, which is coming to half, and this is also 3 by 6, which is coming to half. Is it okay? So, this is your probability that comes in the second step. In the third step, the value of the game will come. If we are calculating the value of the game for player A, then this answer for player A, like you see a 1 and a 2, so you have to find the expected value of a 1 and a 2 using probability. How will that come? 1 into 1 by 3 plus 4 into 2 by 3. So this is coming 1 by 3 plus 8 by 3. That is 9 by 3 equals to 3. Now, the same thing done here, can we also do it alternatively with 1 by 4 or with 5 by 2? Alternatively, can we also do it with 5 by 2? Think quickly. Alternatively, 5 into 1 by 3 plus 2 into 4 by 3. How much is this coming to? 5 by 3 plus 8 by 3. How much is it? 5 by 3 plus 8 by 3. Sir, how did this 5 into 1 by 3 come? See here, from this 5 into the probability that came, here what is the probability? That is 1/3, 2/3, so 5 into 1 by 3 and 2 into, or I wrote 4 by 3, it should be 2 into 2 by 3. You have to multiply by the probability, okay? Like, the probability of a 1 is 1/3 and here it is 2/3. You can also write the probability here. So for a 1 basically you just need to understand that we are multiplying this and this. 5 into 1 by 3, 2 into 2 by 3. So this comes to 4 by 3, so the total is 9 by 3, so that is equal to 3. 9 by 3 is equal to 3, meaning it should come out the same from both. Now, in the same way, if you want to find the value game for B, then the probabilities that have come for B, we can write them here once, they are half-half. So just like we did it row-wise, now we did it column-wise in the case of A. In the case of B, the values for B1 and B2 are given here, so you have to multiply B1 and B2, that is 1 and 5 with this 1 and 2. So 1 into half plus 5 into half, so this comes to half plus 5 by 2, that is 3, and here we normally say minus 3 because this will be a loss for them. If it is a gain for them, then it will be a loss for this one. Or you can do it another way. You can also do it by taking 4 and 2. So 4 by half, 4 into 2 halves plus 2 into 2 halves. So how much does this come to? 2 plus 1 equals 3. But we will write minus 3 because if it is a gain for them, then it is a loss for this one. So this is your method for mixed strategy. So what is the first method for mixed strategy? We do it like a normal sum, just like pure strategy. If we get the answer, the saddle point and the game value is equal, we conclude there, otherwise we move to mixed strategy. So now the question that comes to mind is, if in mixed strategy, a 2 by 2 matrix is not given, then what should we do? For that, let's look at the next sum, it will become clear. Alright, so look at illustration number 2. The special thing about this is that if you just pick up the data and start solving the sum, you'll make a mistake. Here, the data is given, the union strategy is on this side, the management strategy is on that side, and this is the payoff given. So, the management always wants to minimize. The union always wants to maximize, so the union being a maximizing player, the data for the maximizing player cannot be on this side. You have to transpose it, rotate the matrix, and this was the main working here, that you need to transpose it. All the data that has been given row-wise, put it column-wise. The data that has been given like this, put it like that. Alright, the data has been changed. Now after this, we don't know whether it is a pure strategy or a mixed strategy, so we will solve it as if it is a pure strategy. So, you understand that this player wants to maximize, so he will play the maximum strategy. Here, the other side will do minimax, so maximum means first we will find the minimum, then from those, we will take the maximum. So, what is the minimum here? See, here the minimum is 1.4, write it outside. Next minimum, 1.2, write it outside. Next minimum, 0.8, write it outside. Next minimum, minus 0.2, write that outside. If we get the absolute minimum, what is it? But we have to maximize it, so what is the highest? That will be 1.4. In minimax, what will management think? What is the maximum that can be paid? What is the highest coming up? 3.5, write that. What's the highest? 2. What is written? What's the highest? 1.5. What is written here? What is the highest coming up? 3. What is written here? Now, when this max has come, management will think that they have to give the minimum. So what will be the mean? That comes to 1.5. Now, if you see, according to the union, if you check the strategy, the best is coming as you won, its gain is coming as 1.4. And according to management, what is coming is M3 whose value is coming as negative 1.5 and that is negative implied. But since both of these did not match, therefore it has become a non-zero sum game. Non-zero sum game means you can say that no saddle point exists. If a saddle point does not exist, it means it is a mixed strategy game. Which game is this? Mixed strategy. It is not a pure strategy. If it were a pure strategy, everything would be settled here, both get equal A, and our sum becomes 0. So if this is a mixed strategy game, okay, what does that mean? Now we have to reduce this to a 2 by 2. Our first rule says bring it to 2 by 2. Now, how do we bring it to 2 by 2? So, there is a rule of dominance which says that by reducing it, we will make it 2 by 2. So, the rule of dominance says firsts can revise. If it is not 2 by 2 here, then we can write here. If not, use the rule of dominance. Alright. Sometimes, the rule of dominance is the sum of pure strategy, and even in that, it tells you to use the rule of dominance. Keep this in mind. If it is mentioned, then you will have to use it. It means that even a normal sum can be simplified first by applying the rule of dominance, and then you can solve the sum for pure strategy as well. Now here, the rule of dominance says to scan this revise. If you find any row whose values are less than those of another row, suppose all the values in row 1 are less than those in row 2, then you can remove row 1 because this is a maximizing player, right? If you see in any strategy that all the values are smaller and in the next strategy all the values are bigger, we remove the one with smaller values. Now look, this one is smaller, this one is bigger, so it doesn't match. Smaller and bigger won't work. We need all to be smaller. Here, this one is smaller, this one is bigger, so this one became bigger, so it's not happening in these two as well. Then look at these two. In 3 and 5, this one is smaller. Equal will also work. This one is smaller, this one is smaller, this one is smaller. So see, this U4 is smaller, so you can remove U4 but you'll have to write the line. As per the rule of dominance, what are we doing? We want to make a 2 by 2 matrix, so you can say that the value of U4 is less than all the U3 values, so you can eliminate it. In the exam, you will have to write this reason for eliminating U4. So, suppose after eliminating U4 you have a matrix. There is no need to make it again. But you can erase it yourself with a pencil in this question and see. Now you have to repeat this process. Now, see if you notice anything in this. You didn't notice it the first time, but now you might just by looking at U3 and U1. One's smaller, one's bigger, not happening. Let's see these two. Here U1 is smaller, then it became bigger. It won't work. Check in U2 and U3. This one is smaller, this one is bigger. It won't work if the smaller one comes before a bigger one. So this doesn't work. If it fails revise, next check column-wise. Column-wise means now we eliminate based on the opposite party's perspective. So what does the opposite party want to minimize? So if they see a higher value in any column, they will reject it. So when we go column-wise, we will reject the bigger value. In the row, we will reject the smaller value. If you want to maximize, then reject the smaller value. If you want to minimize, reject the bigger value and see which appears bigger. This one looks bigger. Since it's bigger, compare M1 and M2. M1 is bigger, M1 is rejected. M1 is greater than or equal to M2. So, in the eliminate M1 column, reject the greater one. Alright, M1 has been rejected. Now I will go to 2 by 2. Now see, this new reduced matrix is made. Follow this one is bigger, this one is bigger, this one is smaller, that won't work. Then, this one is smaller, this one is smaller, this one is smaller. Wow! So, what is happening here? M3 is getting rejected. If you compare it to M4, M4 will get rejected, the higher value will be rejected. M4 is bigger, this one is bigger, this one is bigger, so M4 will be rejected. The higher value will get rejected. What will you say? M4 is greater than or equal to M3, so eliminate M4, reject the higher value. What happened now? This kind of matrix has come up. You see M2 and M3, and on this side U1, U2, U3. Check 2 rows, 2 columns, the number of columns won't decrease further. There should be fewer rows. Here, this one looks bigger, and so does this one. See, this one looks bigger, so you can reject the smaller one. So now this one will get rejected. What will you say then? U2 is less than or equal to U1, so eliminate U2. Sorry, eliminate the smaller one. You have to keep this in mind. There is often confusion between smaller and bigger, so which ones are left? 2, 1.4, 0.8 and 1.5 are left. 2 by 2 left. You can apply the odds. What do odds say? Work out the odds. How do you calculate the odds? For example, subtract these two and you will get 0.7. Then subtract these two and you will get 0.6 here. Alright, and then if you go column wise, subtract these two and you will get 0.1 here, and subtract these two and you will get 1.2 here. These are the odds. Now calculate the probability from the odds. How will you get the probability? 0.7 by 1.3, so is it 7 by 13 or is it 6 by 13? Calculate the probability here. Here it will be 1 by 13 or 13. Alright, now what do we have to do next? Or you will create a new matrix like this and refresh it. I'm explaining here. Now after this, we have to find the value of the game, which will come by taking the expected value through probability. So, the value of the game for union will be equal to, just take any particular column, multiply it by the probability and add it up, 2 into 7 by 13 plus 8 into 6 by 13. So, how much is this coming to? 2 into 7 by 13.8 into 6 by 13. If you add this up, it comes to about 1.45. Alternatively, you can try from this side as well. You'll get the same answer, okay? If you do 1.4 into 7 by 13 and 1.5 into 6 by 13, you'll get the same result, so there's no need to do it again. But from the management angle, you'll have to approach it from this side. Take this one, multiply it with this and add them up, so 2 into 1 by 13, 1.4 into 12 by 13, 2 by 13, 1.4 into 12 by 13. This also comes out to be 1.45. So if this is profit, then this is loss, so the value of the game comes out to be 0, so this mixed reading is solved. Don't tons. Now just understand it like this. This is the gist of the entire sum. Now you have to do it on your own. See, it is written here using dominance principle, so don't just directly go into the full strategy. First, you have to apply dominance to shorten it. From the dominance, you have to bring it to a 2 by 2 and solve it. If it gets solved through the full study, that's very good. If not, it will be done using the mixed strategy. So try applying the dominance principle here. The reduced matrix has been obtained, and what is happening here is that if you see, the maximum is taken by first finding the minimum and then taking the maximum, and the minimax is found by taking the maximum and then the minimum. In both cases, the answer is A. So these are all pure strategies and the value of the game is 5. A saddle point exists. Alright, these are all pure strategies, so this is the problem and it will be solved easily with pure strategy. So, you should first try to apply the rule of dominance to this. You should observe for yourself how it is working. Now, this is illustration number 4. First, read the question and understand who wants to maximize and who wants to minimize. Alright. So here, Givers and Millen Toys are two toy manufacturers competing to increase their market shares. We are talking about market shares and they want to increase them. For both companies, the marketing team works closely with the design team and always creates attractive toys. These are usually in great demand to meet demand. Strategic options like working for 8 hours a day, so this is their strategy. 8 hours, 12 hours, 16 hours, subcontracting. 12, 16, 24. A 3 by 4 matrix has been given 3 by 4. There is no issue of balance here. A 3 by 4 matrix is given. Find the optimum strategy using the rule of dominance. The matrix is already provided. Just apply the rule of dominance. First, see among these four, what all will be eliminated first. So, try eliminating and see, since the matrix is already given, then check which one gets eliminated. Here, there is G1, G2, G3 on M1, M2, M3, but M4 is getting eliminated because the values of M4 row-wise are such. If we are eliminating column-wise, it means M4 is bigger, the bigger column gets eliminated and the smaller row gets eliminated. Write it down in Hindi. The bigger column and the smaller row get eliminated. In the row, whichever is smaller, and in the column, whichever is bigger. So if it's bigger, it gets eliminated. So this one is left and that one is left. So among these, which one is smaller? See, 10, 8, 10, 11, 10, 8, 9 is not there, 13, 10, 12, 11. So this one is getting eliminated. Which one is getting eliminated? See, for example, if you look at these two, then J2 is also getting eliminated. Alright, you can see that J2 is getting eliminated. But what have they done in the solution? They have eliminated 13 and this one. They have eliminated J1. This may cause a small difference in the answer, but don't worry. Fill in what you think is right and you'll get it. Then after M1, M2, M3, what do you have next? After M1, M2, M3, what comes next? Which one will be eliminated in this? Think about it. Here, something will get eliminated from 10 to 11. From 13 to 12, it's not happening. 8 and 11. 8 and 11. What's happening? Look. See, now nothing is getting eliminated. We are stuck. But 2 by 2 cannot be completed without the rule of dominance, so when you get stuck in such a scenario. This scenario is for learning that further reduction is not happening. But we need a 2 by 2. So what do? We pick any one row, or we pick a column, or even a row, like here. Since there are more columns, we'll pick a column and fix it. We take the average of the remaining two, so the average of the other two is taken. Alright. The average of the other two has been taken, and by looking at this, what do you understand? Is this M1 less than or greater than the average of the other two? If it is more, then we will eliminate it, right? So, if the average comes out to be 9.5, 13, and here it is 10 and 13, if it is more, then it will also get eliminated and your M2 and M3 will remain. The one whose average was taken will remain. So, this is a new thing to keep in mind whenever it is not working out in the end. Like just now there were 2 rows and 3 columns, the opposite can also happen. If there are 2 columns and 3 rows, then fix the first one and take the average of the other 2. So here, the first one was fixed and the average of the other 2 was taken. Alright, so the average was taken and compared. If M1 from science turned out to be greater, then we removed M1 and moved to the 2 by 2 case. After coming to the 2 by 2 case, what are the values of the minimax and maximum? And coincidentally, both values turned out to be the same, so this was the sum of the strategy, and even in the question it was mentioned that it was not a pure strategy, it was just written that you have to find the value of the game. I was reminded of the previous question. If these match, then it's a pure strategy. If they don't match, then we use the odds method. Is it done? See, I have taught the graphical method like this in class, right? I have taught you the graphical method in class like this. So if you are asked to solve the sum directly using the graphical method, it can be a bit tricky. There is no chance of any mistake in that. For now, I would not suggest that you attempt the sum if the graphical method comes. Alright, I am not suggesting that you attempt the sum if the graphical method comes. In my opinion, you should attempt that sum using the normal method. So what should you do? Here, use the odds method and somehow eliminate one option. That means first use dominance to eliminate, make it 2 by 2, and then solve the sum. Don't go for the graph method. It's not even written here that you have to do it by graph anyway. There are certain conditions for using the graph method. The sums that use graphs are usually of the type 2 by n or m by 2. That means either there are 2 rows and any number of columns, or 2 columns and any number of rows. So, like here, there are 2 rows and 3 columns, so in such sums, these rectangular sums, the graph method is used. But even using the graph method to solve the sum is not really recommended. Alright, if you solve it using the normal method, you'll get the maximum value, like here, the 2 minimum and maximum values are 6, right? So just solve it using the normal method. And if you want to eliminate it, can you do it using the average method? See, if we are taking the average, for example, if we fix the bigger value, say we fix 3 and 6, even then it won't be eliminated by the average method. 12 plus 1 is 13. 13 divided by 2 is coming to 6.5. Here 3 is coming. Then with 8 and 2, the average is coming to 6. With 8 and 2, it's 10, and from that, 5 is coming. So this is the average, and this is the actual value of the second row, second column. So it's not getting eliminated. In every way, elimination is not possible here. So the sums that basically can't be solved by 2 by 2, those have to be done using the graph. So the graph-based sum is usually the stubborn one that comes at the very last moment, which can't be solved by dominance. Alright, the ones that just can't be reduced to 2 by 2, the ones we simply can't solve using dominance. We are not able to bring it down to 2 by 2 at all. It's stuck in every way, and this is its best matrix. At that point, it will be solved using the graph. So in my opinion, we should leave that for now. Please, if you get into this right now, you'll just be wasting your time. Making these graphs, doing it, learning it, and bringing accuracy to it is really a challenge. Bringing accuracy to this is really a challenge. Alright, so tell me, but don't think that Sir hasn't taught it. I feel that you might make a blunder in this, that's why I'm not teaching you this right now. It just seems like it, it's not necessary that you will do it. So basically, what is the role of the graph? Let me explain to you what is done using the graph. Basically, the rule of dominance is applied using the graph. How does the graph help? To reduce the matrix into 2 by 2. After that, only the odds method is used, meaning instead of the rule of dominance, because the rule of dominance is not working, it is failing. Even after taking the average, it doesn't work, so this is the role of the graph. After that, the odds method is used. So now, you know, we have some talented students who manage to excel in every situation, right? For those who can do it, it's fine, but for the rest who can't, just leave it. So let me explain a bit about the graph. See, like here, what has been done is 1, 8, 3, 6, 12, 2. 3 strategies. In a way you can think of it like that. Alright, if you look column-wise, there are 3 strategies and we need to remove one column. So which column should be removed? We are not able to remove it using the rule of dominance. So, to remove it, we are making a graph. And how does this graph come here? We put 0 here, make a vertical axis here, make another vertical axis here, and put 1 here. I am explaining this for those students who understand everything, those who can sail through any boat. Those who can't do it, they can leave it. The basic idea is which strategy among these will be eliminated. So here you have 1, here you have 0, and here you have 3 pairs. See, 1, 8, 3, 6, and 12, 2. So 1 and 8 are joined, 1 and 8 are connected here by scaling. Similarly, 3, 6 is also done, and 12, 2 is also done. You can see that 3 lines are crossing here, 1, 8, 3, 6, and 12, 2. After this, what do you have to do? You have to identify its lower envelope. Lower envelope means the lower common region. You have to shade that region and then find the topmost point of that lower envelope. For example, here it is coming as P. So, this point P that is coming here, you have to find out which two strategies intersection it is. If you look carefully, which two strategies intersection is this? This is the intersection of your 3, 6 and 12, 2, which is the topmost point. P is the topmost point of the lower envelope. You have to take that. Alright, and the intersection that is happening there, that will be the strategy. The rest will be eliminated. So this intersection will help you determine which ones will remain. The ones at the intersection will remain. Okay. So the intersection happened between 3, 6 and 12, 2. So 3, 6 and 12, 2 remained, and after that, what happened? Your matrix has now been reduced to 3, 6 and 12, 2. Now apply the odds method to this. You already know how to use the odds method, right? And then find out the value of the game. So this is the main purpose of the graph, and when is it used? When you see that, in any situation, it is not coming down to a 2 by 2. By applying dominance. Understood? That's it. Game theory is finished. Now you have to set and solve all the MCQs. And whatever numericals are there, you should try to solve them and see how they are being worked out. You have got the entire concept now. Like now, this question here, there are 3 and 4. No one has said how to do it, so why should we forcefully apply anything? We'll directly use the dominant principle, apply maximum and minimum directly. Let's see what result we get from that. If the sum gets solved by that, then it's done. So mean, what is it? Not 4, 1 first, then 4, then what is the mean of 4, then what is the mean of 0, then what is here? Okay, mean, you found out. Then, what is the maximum? That is 4. Now, if we find the maximums 7, 7, 4, 5. For these maximums, we find the mean, which is this. Alright. Did you understand? If here, suppose the value of game A comes out to be a 2 and for B it comes out to be 3. This is 4, this is minus 4, so this becomes 0. Alright, so this is a pure strategy. That's it, finished. Why should we unnecessarily go for the odds method or dominance? This is also easy. We won't use the odds method just for the sake of it. First, we'll solve it like a pure strategy. If it doesn't get solved that way, then we'll go for mixed strategy. Alright, now this is the opposite case with the graphical method. Since it's called the graphical method, let's just draw the graph for it. You'll get a bit of an idea. What is the system? What is the system of the graph? What is the system of the graph? Here we will write x equal to 0. Here we'll write x1 equals 1. And now see how the pair will be formed here. Here, since there are some negative values as well, the values will go downwards for the negatives. This scale is for 0. Now, watch how the pair will be formed. The pairs are 3, minus 4, 2, 5, and minus 2, 8, 3, minus 4. Alright, 3 and minus 4. So, you'll have to do the marking here accordingly. 1, 2, 3, so this is 3, and minus 4 will come here. Minus 1, minus 2, minus 3, minus 4, so 3 and minus 4 are here. What next? 2, 5. So here is 2 and 5 will be above 1, 2, 3, 4, 5. So this is 2 and 5. Next, minus 2 and 8. Minus 2 is visible here and 8 minus 2 will come downwards and 8 will go upwards. 6, 7, 8. So minus 2 and 8. But now, since this is an inverse sum, we will look for the upper envelope in this. Here is the upper envelope and now we have to find which is its lowest point. Now, you might say this is the lowest point, but no, the lowest point is actually at this intersection. This is the lowest point. On the lower side, the point of the upper envelope which is the lowest is this one. So you have to identify this. This is your main point. Now, the intersection happening here is between 3 and minus 4 and between 2 and 5. So these two will remain and this one will be eliminated. So what does the reduced matrix become now? The reduced matrix has come out to be 3, minus 4, 2 and 5. Now just apply the odds method to this. That's it, you've got it. The graph is also done. What was in this? Now all these are the same sums. I am not doing them. You have to try these on your own. I just read out question number 6 and made the matrix like this. If the payoff matrix is not already made, then you have to read and make it yourself, then solve the sum, and then there is an extended version of this where you have to find the contribution, make the payoff matrix, and then solve the sum. So this is very easy. You can do it easily. I was making one, but right now I am not discussing it. This will be done. One is recommended that in June 23, a question had come. I have uploaded its solution separately. Solution video. There was an amazing question related to coin tossing in that. So definitely do that one, and every time we are seeing that some question or the other from game theory is coming in the exam, so don't take it lightly. You should understand that questions from this topic are definitely coming. So, apart from June 23, all the sums from CMA Final, SCM and the DJB book that you have prepared, basically all the questions from DJB book, past papers and MTPs, you have to do all of them. Alright, there might be 1 or 2 sums where the answer doesn't match. But use your own judgment to understand what is wrong in it. You don't have to keep sending them to me for checking, brother. I go crazy checking these small things and telling you the answers. Don't take undue advantage of me. Take the basic decisions yourself, whether the institute has done it right or wrong. With this, game theory is finished. Congratulations. Be the stuffing.